This video is for problem 10 on Project Euler, summation of primes. The sum of the primes below 10 are 2 plus 3 plus 5 plus 7, which we get 17. Find the sum of all the primes below 2 million. We know that finding primes can be really expensive. They can take a long time if you have the wrong type of algorithm. And typically with these Euler problems, I will look at previous problems to see if I can salvage some code, and we can actually salvage one of the methods that we wrote for one of the questions, which is to find prime numbers, and that one was pretty efficient. Also, we know that 2 million is a pretty huge number, so this might not fit in an int or a long. I'm not sure, so I'm gonna go ahead here and use a big integer just in case. Yeah, so let's go up and let's program. Okay, let's have some fun. So like always, I'm gonna pull the project where I solved my Euler questions, and so I'm gonna create a new one. I'm gonna call this one summation of primes. Okay, so we have that. Alright, so I know that we had that prime method somewhere, and I think it was largest prime. Nope. It should be, let's see, which one was it? I'm lost. Nope. Oh yeah, this one right here. 1001, 10,001. Okay, I guess it's 10,001 primes. All right. So what we can do is we can salvage this, and I guess I'm just gonna rewrite this inside of our summation of primes. Just for people that haven't seen my other videos, they can just go ahead and see how to get this done. Okay. So I'm gonna rewrite this, and I'm gonna use int because I know that 2 million fits within an int, so I'm gonna rewrite this. All right, so this should be a quick one. So what we need a private static boolean, and we're gonna call this is prime, and this is gonna take in an int. This is gonna be number. So what I want to do first is create a variable to hold a counter. So say counter is gonna equal to 0. And then we need a square root, so I'm gonna create another variable to hold the square root. This is gonna equal to cast it math dot square root, and we pass in a number. All right, so now that we have that here, let's go ahead and create our for loop, and we need this loop to start at 1. So we're gonna say var x equals to 1, and x is gonna be less than or equal to square root, and we'll do x plus plus. Next we're gonna say if number, right, mod x equal to 0, then we can go ahead and increment counter, so counter plus plus. And we're gonna say if counter is greater than 1, then we can just return false here. If you haven't seen my explanation, please look at my other videos for the 10,001 primes. And if that passes, then we can just go ahead here and return true, and we found the prime. Alright, so now we have this here. Let's go ahead here and actually find the summation of primes. Okay, so we need another method here, and this is gonna be I'm gonna make this big integer just because I don't know if it's gonna fit within a long or not, and I'm gonna call this one summation of primes, and this is gonna take in an int. I'm gonna call this the limit, which is gonna be our 2 million. And what we need first is to create a variable, a big integer. I'm going to call this one summation or sum. Should be anyhow you want to name it. And this is going to be a big integer dot 2. Oh, the reason why I'm using 2 here is because if you go back to the question, we see that 2 is the only special case here. So if we start our loop at 3, we can skip 4, we can skip 6, and all of the even numbers. Okay. So what we're gonna do here is create a for loop, and this is going to be where x equals to 3. We're gonna say if x is less than the limit, we do x plus equals to 2. So we only get the odd numbers, and we're gonna say if is prime x, then we will say summation equals summation dot add big integer dot value of, and we're gonna add in x here. Okay, and we can just go ahead and return summation. Alright, so with that done, we can go ahead and create main, and we can test this. So this always has to be public. Alright. Alright, so we can do SRT here, and we can use submission, and we can pass in 2 million. I'm just gonna put underscore here so it's clear, and let's run this. Alright, and we get the solution. So what I want to do is I want to see how fast this runs, just because it's good to know how fast your algorithms are. I haven't tested this, so I don't know. And I'll get system the current millis, and I'm gonna go over here and I'm gonna do another long. I'm gonna do end. It's gonna be equals to system the current milli. And next what I'm gonna do is just print out the time in seconds. So what I'm gonna do is SRT here, and I'm gonna do start, actually end minus start, and I want to cast this to a double, so I'm gonna do a double here, and then I want to divide this by 1,000 so we get the time in seconds. Okay, and this should work. Let me go ahead and run this again, and we get roughly 0.453 seconds. So this is a pretty good algorithm to solve prime numbers. So if you guys want to just figure out how to solve this, get this prime number algorithm, look in my previous tutorial. I actually show you guys how to get this. If you guys want to get all of the factors of a number, this also works as well. So look at my other videos and you figure it out. And by the way, like I said, these tutorials are for people that need help solving the Euler projects. If you don't need help, then there's no point of you being here. If you have a better algorithm to solve the problem, please let me know. Put it down in the comment section below. And I'm always glad to look at somebody's code and to understand how somebody else solved the problem. I will see you guys in the next tutorial. Please like and subscribe to my channel. Bye bye.